Okay, so here's all it is. You can pretty much see everything in this shot and how to build it. But for a demonstration, the input is on and the output is on. The input is off and the output is off. Now when we flip this lever and charge it, now the input is off and the output is on. Input is on, output is off. And we can tile these, well, almost tile, stack these, and control all the adjacent ones with one line. Let's build the inverter. Let's put a lamp for our input just so we can see what's going on here. And then we're going to build the first splitter. We'll put a temporary block right here and a lower block. Knock that out. We're going to make this wall 2 blocks tall. And then on top of this coming back, it'll be a half slab. Now when we put our redstone dust down here, it can charge that block. And it can jump up top and it can go across the top. So we're going to put a torch on this for the lower line here on the bottom of the split. And then we're going to put a temporary block right here. And that's a real block. This is going to start our T shape, 3T across and 1 down. Now we're going to put dust across the top of that, a torch on this end of it, and also a torch under here on this part of this block. That's going to keep this line energized and always keep this torch off. Now we're going to put a temporary block here and a real block there. We'll build this out. We're going to put a torch here. This dust will be our output, and actually, since that's going to be our output, I'll put a lamp right there for now. Now, we go back to the bottom down here, and all we need to finish this up is one more piece of dust. Now, this is the main part of it, but in order to make it switchable, we need to charge this block, which will turn this torch off. So that way the signal can pass across. Right now the signal across the top is blocked. So we're going to put a temporary block there, and it doesn't have to be a slab. I just like to use slabs. And then we're going to charge that with a repeater. Let's get a lever on here so we can turn our inverter on, and it's working. That's inverted, and that's normal. Off, on, off, off. Now we turn on this, and we have off, on, off. And then we switch it back. Now if we want to tile these together, we just take the output off of this right here, put a temporary block and then a real block, and then we can put a dust, and this repeater will actually charge that dust, and we can link along a ways down and build another one right here if we want, or we can just start another one directly adjacent, just put a repeater coming out of it like that, and then we can build another inverter right here and have them tiled, something like this here. So I have 3 inverters and I have 1 line skipped right here. See, I jump across and go to the next. Now when we flip the inverter bank, I suppose, on, we have the 3 inputs inverted, and now let's switch. Now we can switch it back. Now, where is this device useful? Well, like in this case, here is a 4-bit adder, and we have all of our input B's on the inverters here, and input A's, like see, you got A1 and B1. Well, A, your top number, just skips right through and it's always normal. B, your bottom number, goes through the inverter. So if you want to make your adder, and this is a more traditional ripple carry adder, but the the functionality is the same between most adders. You have to invert B, input B, and you have to turn on the carry in at the same time. So what we do here is when I flip that lever, it turns on the carry in for the adder and it inverts all of the input B's. Also, when you're in subtraction mode, the carry out means something different. So, for instance, in addition mode, the carry out 16, but in subtraction mode, it just means a positive number. If the carry out is off in subtraction mode, that means you have a negative number, where your input A is smaller than your input B. So, let me just demonstrate real quick what's a good number. Let's go with 8 plus 3. We'll go with 8 plus 3. So there's 1 and 2 on input B, 8 on input 1, and the adder is spitting out a 11. Now we go ahead and we switch it to negative mode, subtraction mode. And so we're inverting, what we're doing a couple things. We're inverting input B into the adder. We're turning on the carry in. See, that's coming through here. And also what I've got going on as far as the signal coming out of the inverter line, I have it blocking off the carry out because, well, for instance, what did I have in there? 8 and 3. So what do we got here? 4 and 1. So we got 5 out. So 8 minus 3 is 5. If I didn't have this blocked off, it would look like 21. But really, all it means is positive 5 because the carry out is on. So that's for this setup. It's just how I have this one hooked up, which just makes it work a little easier, and the fun redstone calculators that we build. So I think I've done enough babbling for this video and flying around too much. But anyways, that's the inverter system right there with no pistons, and can make your traditional ripple carry adder. Well, pretty much most adders subtract if you wire it in properly. Alright, thanks guys, and I'll catch you in the next one.